Welcome and thank you for standing by. At this time, all participants are in a listen-only mode. To ask a question during the question-and-answer session, please press star 1. Today's conference is being recorded. If you have any objections, you may disconnect at this time. Now I will turn the call over to Ms. Lorraine Fernandez. Ma'am, you may begin.
Thank you and good day to everyone. Many thanks for joining us here on our call today as we're doing the first of our series of webinars, particularly for the IBM Initiate install base, but for our MDM customers and the healthcare community in general, to address the fact that there is a lot of conversation going on today, irrespective of which country or which continent you happen to work in, live in, be a consumer to healthcare in, because transforming healthcare is important to each of us in a myriad of ways. So the webinar series that you're joining today, and you'll see on the slide we have 2 more planned for November and December, as well as others planned in the first quarter of 2013, are going to highlight the role and the investment perhaps that you've made in master data management, with addressing perhaps your patient domain as the first area of interest. Many of you on the line may also be using our technology to address the provider domain of master data management, and we'll explore other issues. So we're starting this series today with discussing the Clinical Hub and MDM, and specifically operational analytics. You can also join this conversation through our MDM blog and IBM's Big Data blog. You see that the links for those are included in this slide and are available for you, obviously, anytime, any day you want to join our conversation. So it's with great pleasure today that our speaker is Dr. Scott Schumacher, who is the Chief Scientist for InfoSphere's MDM portfolio. Many of you know Scott and myself from our years of working with the Initiate technology, and we joined the IBM fold about 2.5 years ago. So Scott serves as the Chief Scientist for MDM and is a distinguished engineer at IBM. A few housekeeping details before I turn the program over to Scott. We will take questions via audio at the end of this call. We will also take questions throughout the webinar that you can submit via the chat room. So I'll make sure that those questions are queued up for Scott and perhaps the product management team that is also joining us, Deanna Noel and Joaquin Neto, and we'll address those at the end of our webinar. You'll notice in the chat room I posted instructions or information about how you were able to get the slides or the audio next week following our webinar. So Scott, with that, I'll turn the program over to you to enlighten us about MDM, Clinical Hub, and operational analytics.
All right. Thank you, Lorraine, and good morning to everyone, or good afternoon, depending upon where you are. With one of the things that we always start with is that the usual disclaimer. So this is the legal requirements for having these discussions. And then what we're going to talk about here are products in development and future plans. And so we keep in mind that those things can, in fact, change and often do. But the discussion today is really around how we are using MDM to support really what we think of as a new type of analytics. And as the slide shows, it's sort of the standard stuff would be that your people are all aware of are population-based analytics, and these are things that are usually satisfied by data warehouses that combine some clinical information, patient demographic information, financial information, other operational information, perhaps supplies, et cetera, that allows people to do queries and reports, typically retrospectively. These are, the standard data warehouse retrospectively, how many people were in last month, et cetera, reimbursement information at that. So that, and with certainly the changes in healthcare, accountable care organizations, and other sort of shared risk models, those become very, very important to know how much money you're spending on a particular operation, how much revenue you're getting for different pieces of this. So those are very important things, and I think most of our customers are moving along the lines of creating some sort of a data warehouse to support that. Sort of on the other extreme for that are patient analytics, and that's really sort of in the doctor's office treating a patient, and that's basically done with EHRs or other technologies that way. So is there a drug interaction? But that's at a patient level, and that's a physician treating it. Well, it seemed to us when we started talking to many of you and many of our clients that perhaps there was something slightly in between there. And what we're calling that is operational analytics in the sense that it's like the MDM, like the EMPI. It's in a real-time setup or near real-time, feeding off of messages that you have. But it's asking questions really sort of between these two population and individual patient areas, which is really going around cohorts. What patients are similar, and what capabilities does that give me if I can, in real time operationally, ask questions such as, if I have a particular patient in front of me, what other patients that we have seen over the last 5 years are clinically similar to that? So being able to bring out statistics around cohorts and being able to search around cohorts for that one. And there's a lot of different ways to use that once you have it is, what can you say about, treatment characteristics for a group of similar patients? How can you analyze those? So if you then get back to the issue of, once I've got these sort of separations, can I combine in financial information and do other pieces to it? And then also, thinking about this as a real-time system or a near real-time system, you can support, day-to-day operational issues, such as if there is a rare event within the hospital or within the delivery system, ask, are there other patients in the delivery system now which are similar to this? So you can start to do, an analysis on those events, but also perhaps maybe do some remediation and do that one. And one of the other ones which is sort of key is when you think about cohort analysis, you think about supporting patients for clinical trials. So all of these really are sort of tied up in what we are calling operational analytics, which feeds between these two pieces of it. And that's, so when we started to think about the requirements of that, being able to search for patients based on clinical information, having some sort of similarity calculation, being able to support the loading of this data near real time so that you can support operationals, really sort of operational things. It's really sort of sounded a lot like an MDM solution with some analytics and some analysis built into it, but an MDM solution that's keeping track of some sort of clinical data that supports these operationals. And that's what we want to sort of talk about here. One of the so again, getting back to it, it's really something to support cohort selection use cases if you want to do it. And there's a number of reasons in addition to, for doing this. One is for analysis. Similar patients, what were the outcomes, what were the events? Can you start to use this to break apart your population, try to understand what you're doing and what you're doing now with a set of patients? And then again, to find people for clinical trials. That's all based really on a set of search criteria that I want to be able to go against a longitudinal patient record. I'll build this up over time so then I can search for patients and I can search for them for different purposes. But again, based upon sort of real-time loading of the data. And that's what we're doing, and we're calling it a clinical hub, and we'll probably rename it 4 or 5 times before we finally get it out there, is our way. But what we've done is we've taken our MDM solution, which you're all familiar with as managing patient demographic information or provider demographic information, and we've extended that in a way where we can store in there a longitudinal patient record based upon clinical data. Now, as you all know, that sounds a lot easier than it really is in practice, and we'll discuss some of the issues that drive us that give us some problems there and some of our solutions with it. But the key piece of this is an MDM solution that's managing some set of clinical data, and we'll talk a little bit more about what that is. And then the second piece of it is I think, some capabilities that we have found from IBM Research, who have been really working in the health informatics area for a number of years. And some of the capabilities that we're taking from the research folks are algorithms that match patients based upon clinical data to find similar ones. And we'll talk a little bit about how that plays through in being able to do searching. Just as now when you search on an EMPI for a particular name, or based on a particular set of demographics information, we bring back things that are close to that. Same thing is the case here using these algorithms, so you can bring back things that are not just exact matches. So the key thing with that is when we talked about this, we wanted this to be similar to an MDM in a real-time operational setup. And that really meant that what we had to do was to get as much information, clinical information, on the patients that we could via the existing message infrastructure that's in place. So reports, diagnostics information, lab system reports, orders, etc., get fed into this, and we parse those in the same way we handle HL7 ADT messages now. Although, now you've got to do a little bit more work. There's doctor's notes in those. If you've all looked at HL7 messages, there's a rich set of information in there. And it tends to be in different code sets, so there's some normalization there. One of the other key things that we wanted to do with this product is to be able to have a system that the IT staff could give to the researchers and give to the informaticians and the clinicians, that they could do self-service searching. Right now, if I'm going to go look for, say, a set of clinical trials, and I'll use that throughout the discussion, throughout the presentation as sort of the canonical case, what happens is a researcher writes down a set of things for a query. He hands it to the IT department. They execute the query. They give him back. He says, that's not quite right. He modifies that, sends that back to the IT department. They do the query, and it goes back and forth. Well, that takes a lot of IT resources. That takes a lot of IT time. That's not very efficient for the researchers. So one of the requirements for this product was to create this in a way that it could be self-service. And the thing that supports that is one of the reasons you don't want them mucking around in your data warehouse is that there's a lot of information that you wouldn't want your researchers to see, the demographic information, et cetera. So this clinical hub, this separate model, is a de-identified model. And to be honest, to be clear on it, it's a HIPAA limited data set that we have in there. So you can allow researchers to have access to it, but it's linked over to the EMPI where all of the demographic information and the identifiable information is kept. So you can allow physicians and you can allow researchers to do self-service queries upon this and then speed up the results of doing clinical trials. And the one application that we have built on top of this is, in fact, something that allows you to search for patients based upon, cohort selections. Again, kind of aimed at clinical trials or finding patients for clinical trials, but it can be really used in general for searching from that thing. And I think I've covered pretty much the key benefits there. It's really to get researchers, informaticians, and operational people access to clinical data in, sort of near real time as soon as the message can get processed, and allow them the ability then to search this with the same rich capability we bring to the demographic searching on EMPI. We bring it for clinical data, again, using the information from our research pieces. So there's really sort of two kind of interesting things to this piece. Boiling down a year's worth of work to two pictures on one slide, we say it in this way. The key thing is to be able to put together a longitudinal patient record and to do so in a normalized set of information. So we translate things, we do the processing, and we translate to standard code sets, SNOMED, Rx norm, et cetera. And so there's the issue of normalizing the data that's being in there, and then we build this longitudinal patient record. Now, of course, the EMPI, which is the one that's keeping the track of MRNs to exact EIDs, sorry, I shouldn't have used EIDs, to enterprise identifiers that's identifying the same patient across the enterprise is key to doing this. And that's one of the things, no matter what you're doing in terms of analytics based upon clinical data, an EMPI is a critical component of that, so that you have the same records for that, you have the complete set of information for the patient. And so that's tied in here in creating this one, but then it's also creating the longitudinal and the time series information that allows us to apply analytics to it. So it's got to be normalized to similar terminology. It's got to be created in a excuse me, in a time series manner, and you've got to be able to then, search and analyze on that. The second key piece of this is really the notion of similarity. And as this diagram sort of indicates there, and there's a number of ways of doing similarity. We can discuss that one a little bit later in a little bit more detail. But essentially, you're taking the clinical information as a set of vectors or set of features that we have within that, and then finding ways to measure closeness across the patients that would say, these sets of features that I have for this patient are sort of similar across, measure that similarity, and then use that. So the notion here is that searching across clinical information is much more complicated than demographic information, and this multidimensional similarity is the key that allows us to bring together patients that have sort of similar treatments, are taking similar drugs, have similar diagnoses, as similar age, weight, et cetera, biographic information as well, that we've built together, and then allow you then to search. So you can find, probably the clearest way of thinking about this is, if I've got a patient in my hand, find me more like this, if you like the Google analogy of finding patients. And so those are the two key technologies, and it's all built around creating, managing, updating the longitudinal patient records with information that we're pulling from clinical HL7 messages, as well as putting them together once we've got that information, creating this similarity algorithm, very similar to what we do for likelihood processing in the EMPI, but really just to find groups of cohorts, patients that belong together. And so one of as I mentioned at the beginning, and I want to get to a sort of an example of how we're doing this, of what this looks like and why we think it's a critical thing. And one of the applications that we're beginning with really is sort of the clinical studies. And so what we've done in building this UI is done something where we sort of model the type of information that you would see for a clinical study, and then allow you to then go search and play with it. The other key to this one, too, I think that one of the important issues is to make it fit within the enterprise. And when we talk about automatic data building, what I mean is that this sits within the infrastructure that you have in place now, where you have clinical information that's flowing between lab systems and order systems and EHRs and other systems together, that bringing that information that's already available within the environment, within the enterprise, and building it from that, so that it's not intrusive as you think of most clinical analytic systems. And then last is now creating a search engine to do with it. So now this is a much more complicated search structure than you think about when you talk about the EMPI, where you're really searching along, a handful, maybe 20 attributes. Here, the space is much, much bigger. So we need to think about how we're doing, searching within this model, both for exact searching, because that's certainly part of the game. I want to go find out who exactly matches a particular set of things, but then also for this fuzzy piece of that. And then how do you sort of work through this piece of the puzzle for doing it? This one just sort of gives a list of the information that we're trying to carry about a particular patient, and I think probably just sort of focus on the first piece there for a minute, because that's where all the sort of heavy lifting is that capturing information for the patient's longitudinal clinical history. Again, diagnostic, vital symptoms, medications, if you can get outcomes, if those are available, but then information that you've also pulled from reports, and then notes. One of the key things, as we all know, is that within the healthcare environment, there is a lot of very valuable information that is in unstructured text. And so this is not built strictly on structured information that we get as part of the HL7 messages, but we also get the unstructured components, which would be sort of included reports in the ORU sections of the piece of it. And we apply text analytics on those in order to find out that a particular all of the information that we can about a particular patient. So this has a text mining operation as part of it, in addition to sort of the structured, discrete data that normally comes with an HL7 message. And that's where you get things like family history, et cetera, that's not typically codified or it's not consistently codified. And it's also a way of getting at doctor's notes where you can find things like smoking or non-smoking. Those information which are really in text, but also information from lab reports, et cetera. So structured and unstructured data are part of this. If I pause for a half a second, you'd say, well, okay, then there's other information such as metadata associated with DICOM. Maybe I could do image analysis, et cetera. And that's an active area of research, by the way, of can we do some image analysis in addition to this. But we'll park that off to the future. But as a teaser, there is more going with it. The other piece here I'd like to mention is really sort of a problem that we have independent of whether you have a clinical hub doing operational analytics or not, and that is the maintaining of sort of the knowledge sources. So we all know and love ICD-9, 10, and those, but there's a lot of other code sets that are available that are out there, and there are some people that there are some products you can go purchase that help you manage all of those things, but then there's also internal code sets that your system generates that need to get translated from this system to RX norm, et cetera. So one of the things that we've discovered as we've gone into this is that being able to manage this reference data to do so in a single consistent place is a very valuable thing that comes along with this solution. So reference data management is a big problem within a hospital environment, not so much ICD-9-10, but it's in the translations and maintaining all of the transcoding tables that you need to do to run your service bus, et cetera. So that's another piece in there that's part of this solution that we're building is a way to manage that stuff in a nice, consistent way, publish out transcoding tables if you need, push information into the clinical hub. So again, that's a good part of the solution. And last but not least, and I think this is, I worked with a guy who started and stopped every meeting with the phrase, security has never been more important than now. And security and privacy has to be built into this. That's one of the reasons we use the EMPI technology for managing this, because of the attribute level controls of it, and that's why we've come up with a separation of these data to keep the identifiable information separate from the clinical information. And again, it uses the same role-based access, et cetera, that we know and love from the EMPIs, and then we've also built into this capability the anonymization and data encryption capabilities to keep the clinical side of the game, clinical MDM component of it, available for self-service. So these are kind of the key things to them. And this one here just shows what's if you think about, again, getting back to looking for patients, one of the things you do is, within the clinical protocol things, is it boils down to a set of inclusion and exclusion criteria. And when we looked at this and we studied a number of these things, we decided this really is a good way to think about not only searching to match this problem, clinical trials, but it's also a good way to search in general, or at least to start your search. And I think that the key thing to the Clinical Hub is that this is a good way to start your search, but the similarity is the better way to conduct the search once you get started. So here you've got a situation where you've got some eligibility issue, and then you've got things that you want as part of the inclusion to it, and then you've got things that you absolutely don't want them to have. And so what we've done is that we've sort of we've mirrored that component in our UI. And so this is the UI, a screenshot of the UI that we use for the Clinical Hub, and you can see it's got two tabs at two tabs at the top to talk about inclusion and exclusion criteria, and then these little twisty drop downs where you can actually start to enter information. So if I twist down the demographics, for example, I have this, and it's use a Mad Lib type approach, a way of entering information that I want for demographics, family history. And so the two here that we have done are demographic information and a disease condition, cardiomyopathy, that we're looking for. So this is an example of the type of thing you would want to do if you're trying to find some patients for a clinical trial, or perhaps find some other patients that, for other reasons as well. If you're looking for people within the hospital right now that have a certain set of problems, you would run this sort of thing. The problem is when you typically fill all of these things out, you get very rich, and you get the answer that nothing's in there. So the exact search capability is one where you very quickly get, bounce between, I get a million responses, and then I get 0 responses, and then I get, 500,000 responses, and then I get 10. And so the researcher ends up going back and forth with this capability by just sort of modifying the pieces of it. What we've done with the Clinical Hub is to say, let me take those inclusion and exclusion criteria that I had and put that in really as a virtual patient, and then use my similarity to this sort of fictitious patient that I've created, and use my similarity to go find things that are out there. And so this is an example of that, where we have used this, this virtual patient based upon what we typed in before to go search the database and come up with things that are close to it. And I apologize, this is a little hard to read even for me here. But what did you get back then is a list of patients, a score. This is, for those of you who use the EMPI to search, that should be pretty straightforward. And then information about those patients that you can use to select of it. And then also on the top, there's certainly distributions that you can look and see, well, okay, I wanted females, but I got a couple of males out of this, but that was because they matched some of the other criteria very closely. So you see that I've expanded the search, and I've got things, I've got now a sort of a fuzzier distribution of if you look at ages, we're going across a wider range, and the same thing with weight. So again, it's sort of expanded it, but then it's brought things back that are close to this patient in other ways. And so then one of the next thing to it, and this is kind of the real cool piece of it, is to say, now let me take a couple patients that I like in here, and you can pick as many as you want, and you say, okay, now these are really, if I want to think about it, these are the patients I'm looking for. These are the canonical ones. So now then can I go expand this search and find more like me based upon clinical similarity. So there's no demographics involved in this, et cetera. It's all algorithmically clinically similar. So the researcher would go through this expanded list, select the ones that he thinks are closest to the type of patient that he's looking for, and then he would say, okay, now go find me more like this. But it would use, instead of the original limited sort of information that he put in on his inclusion criteria, it uses the complete record for each of those patients and then pulls back similar ones to that. And then we do some color coding so you could kind of see similarities between the two things. Again, for those of you who use Inspector, this should not be a surprise in the sense of color coding to show similarities and differences. Scores over there that show how well it matches one or the other. So this gives the researchers a way to go through and find patients for clinical trials and do so in an efficient self-service way. We can, we also, support exact queries, et cetera. But I think the key to it is to be able to do the more like me. And again, that's the things for not only clinical trials, but if I want to find, there's a patient that just came in, finding more like that particular patient if I'm interested in looking at coordination plans or treatment plans or outcomes. So again, it's a way of operationalizing clinical data and getting it into the hands of the researchers, of the informaticians, as well as operational personnel. So that sort of is an example of what it does. Let's take a quick look at what it looks like in terms of an architecture point of view. And so go with this. Let's start in the middle and move out, because the middle is really the MDM solution that we all know and love, slightly modified. So that is the MDM solution. So it's a standard initiate, what we call standard edition now, data engine. And we've configured it with our clinical data model. We have added in there this ability to do patient similarity. And one of the things that we introduced several releases ago within the initiate, back when we were initiate, was the notion of, well, we want to do more flexible searches than are supported by perhaps just the algorithm. And so the way we did that was we added the capability of creating a full text index or a Lucene index. That's the type of thing that Yahoo and Google use to do text searches. And so that's an option now within MDS, and we've used that option as we've built out this clinical hub. The other component, one of the components which is new, is that we call it an MDSI. And it's an interface that's really specific for clinical information. And so rather than just, we always had data that we could derive web services and derive Java objects for an API from the data model. But here we've gone to the case where this is complicated enough, especially when you talk about inclusion and exclusion, is that we created an API sort of specifically for dealing with clinical information that also hits the Lucene index, et cetera. I mentioned vocabulary index and reference data management. That's a key part of it. We have solutions within the Infosphere area, RDM, and we're building that component in with this one. But so the centerpiece with the security and user management essentially is what you know and love as the Initiate EMPI, but with a completely different data model, some new search capabilities, different set of algorithms, and some new APIs. At the top is one of the data collection, and the data collection here is of course much harder. We're building around WebSphere Message Broker, and incidentally, we're shipping WebSphere Message Broker with our next release coming out this quarter, which is in 10.1. So you can start to use that technology for doing managing of HL7 messages, et cetera. And the good thing about that is that that's a technology that we're using across IBM as well as for this particular application, but for other pieces. So the WebSphere Message Broker does the HL7 parsing, if you want, and then within that we have added a couple key features within that technology. We have added one. And I'll explain this one on a separate side, a way to de-identify information within the HL7 message before I pass it into the clinical hub. And that, of course, ties over to the EMPI, where you're normalizing MRNs, et cetera, to enterprise identifiers. And then we have, as part of that, we go through and we parse the clinical messages. We also have really a very specific text mining approach that we use for healthcare data to build out and take the information from the unstructured components within the HL7 messages and structure those in such a way that we have those available within the clinical hub. As a quick aside, one of the issues is that, anything that you're doing with text mining or inference from text, you have a higher chance of errors than you do if you think, if you get a declared thing. So we highlight that information when you're getting search information back as to what information has been inferred from text and what information is declared as part of the structured data. And then at the bottom is really the application that we have built on there now. We have a number of other pieces to it, a report if you actually want to go in and find a patient's LPR and look at it. So there's some utilities that go with it, but the basic thing then is the Clinical Hub application. In terms of expansions, if we think about, okay, one of the things that we always do if you're in this line is even before we've made the first one, we always think about what the second one might look like. And the expansion areas there really are in two directions. One is to maybe go to a larger set of sources of data to build out the patient model. We're not trying to be a data warehouse. We're not trying to be an EHR. We're trying to create this information so that it's searchable, usable, et cetera, within an operational context. But perhaps there's some more information available that I mentioned earlier, DICOM metadata, or perhaps image analysis. So that's one natural way of expanding it is to add these components that I can plug into Webster Message Broker. And then the other one is to say, okay, I've got a search application. Are there other applications or are there other uses of this that you would like to tie into? Is there information that you would like to put into a referral system, and so you would want to be able to query a clinical hub as part of a referral? So again, thinking about different applications and different APIs that go through it is probably the other way we would want to expand it. But this is the high-level architecture. Fundamentally, it's the master data service, the MDM solution we know and love, beefed up a bit in a few areas, as well as the data collection component, a data ingest component built upon WebSphere Message Broker that is using HL7 sources and applying this sort of text mining and de-identification to it, plus then the application layer, which allows people to get information to it. So that's sort of the bits that we're shipping as part of this. And that's it. This one I think I described earlier, but let me go spend 1 minute on this one. Is to say that when we take this information, an HL7 clinical message, we get that before we do anything with it. We go make sure we know the patient. We know it's MRN, and MRN gives us an EID. We take both of those pieces of information and we go back through it. And then we use the information that we have, the demographic information that we know about the patient to de-identify the information within the rest of the HL7 clinical message. So I know the patient's name, and so I know if that patient's name is mentioned in a free text form, I need to anonymize that. And if I know, if date of birth we leave in here, but if there's other information that is part of the unstructured data or the structured data that is related to the identifiable information that we keep in the hub, in the EMPI, we anonymize that, we encrypt that. So we have encrypted identifiers. We don't have MRNs and EIDs or any of those other things. They're encrypted versions of that that allow us to tie back to the EMPI. And then we also use, as part of our de-identification process, the information that we have from the patient's HL7 message, but then also from the EMPI. So we anonymize names, et cetera. They get stuck into the HL7 messages in different places. So we are really working very hard to keep the information in this clinical hub as a limited data set. A limited data set, the key difference there from our point of view is that we like to keep exact dates of treatments. Birth dates we don't care as much about, but exact dates of treatments is key to being able to put together our longitudinal time series record. So this is a key piece to the technology, and we think that that's something that would be good for also supporting data warehouses and other applications. And really this is kind of the, if you want the family jewels to the system, and that is how do I find similar patients? And the technique that we're using in this version, and as I mentioned at the beginning, there are multiple techniques. This is the one we think we will stick with, is a multimodal fusion, where we do some processing by similarities. We get that into a time history, so I can look at, I measure, I align the patient's time histories in a way so I can say, okay, are they doing things in the same sequence as part of the similarity? Because order is important in sort of treatments and drugs, et cetera, and results. So we use the time series to align these people, and then we fuse the information together once we've got that similarity. So that's a key piece to the puzzle. And sort of the last sort of architectural diagram is how does this fit really into the larger system? And so this, again, the clinical hub is really tied closely to the EMPI, and it's getting information from the service bus, and it's getting clinical information, ORUs, ORMs, et cetera. Now, that can also be fed into a data warehouse and then combined with other information. So we see this as really sort of a separate piece from a data warehouse that's supporting operational instances that are, again, de-identified work, whereas the healthcare provider data warehouse, with Cognos or BI, whatever your favorite one is pulling in, non-HL7 messages that it's going. One of our products there, ICDA, is very good at going through file systems, file management systems, and pulling information out. And then financial systems, and then those are integrating those better in a data warehouse. We're really worried about the clinical information that's readily available from the HL7 messages. But obviously, the techniques that we use for doing the parsing of that information can feed either side. So I think I've summarized this, and I think left a few minutes for questions here. That really this has been a great, from my point of view, the perfect storm. That we've got we've got some work from the software group, sort of standard technologies that we can use. We have some key capabilities from IBM research that's really, I have to sort of personally say, one of the best things about being part of IBM is the breadth of the people and the knowledge and the interesting things that they're working on. Not to mention, really just a bunch of nice guys. But one of the fun things is to go and talk with the research and get information from them, technologies that we can make as part of this solution, and really sort of, I think, advance the state of the art and do so. And the third piece I have to mention, of course, is customers. We are doing this with a POC with a great customer, and they really sort of keep us all honest on usability, accessibility, and the other things that go in with making it. So, from my mind, this has been a great example of a standard software development organization, as well as a research organization, tied in with a good customer and being able to develop this solution. And so I think I've sort of summarized most of the inference there. But, again, think about this as the technology you know and love is part of your EMPI, or know it, not necessarily love it, but as part of your EMPI, extended for managing clinical data. And then with these components from research to do text mining and text identification, de-identification of information, the terminology normalization, and doing a lot of the patient similarity. So again, a great combination and a great work with it. For the attention and listening today, and if you have additional information, here's the usual list of suspects that go with this process. Again, Lorraine and I have talked, but then Michelle, Joaquin, and Deanna. So, Lorraine, I'll turn it back to you.
Well, thank you, Scott. Great presentation. I enjoyed it, and I've heard it before, but I enjoyed it again because I learned something new all the time. So I have two questions for you, Scott, based upon what's come in via the chat room. Number one is you made a reference to the warehouse and the clinical hub is not trying to be the warehouse. Do you want to spend a minute talking about how this approach complements a warehouse?
Sure, and it does it in the same way. Let's just get out of healthcare for a moment and talk about an MDM solution and a data warehouse. So within an MDM solution, you're really trying to master and control data, and you want it data. The type of data you try to master is data that you want available, all the time. So through sort of standard services that you will, support different applications and different activities within the enterprise. So that's essentially MDM, getting a certain set of data together that really sort of supports the real-time operations and running of the enterprise. A data warehouse, on the other hand, typically is used as a retrospective piece. So it tends to have more information within that. It tends to have, highly volatile information, daily heartbeats, if you want, or count balances. So it's really meant for sort of retrospective analysis. And I think the same division applies here, where the information that we keep within the clinical hub is a subset of all the clinical information available that would be as part of the data warehouse. But it really is more designed to be available, searchable, real time. Operationally, that's I think the key word is, as people walk in the front door, can you use that data, the data you have, to support how you're going to move them through the enterprise? Whereas the data warehouse is really sort of telling you how you have done. Maybe you're using it also to predict how to do things in the future, but it also contains more dimension, what we call more dimensions of the patient. It can contain the financial information. It may contain more of the insurance information, as well as perhaps deeper clinical information that you just can't process. I mean, it's very difficult to think about doing video analysis in real time as part of an operational system, but you could use that to support a data warehouse system. So again, I think that keeping in mind the same distinctions between data warehouse and MDM that apply in commercial businesses, I think also apply here.
Okay, good to hear. Operator, we should open the lines. I've got several questions in the chat room now, but let's open the lines to take a couple of questions via audio if we have them.
Thank you. If you'd like to ask a question, please press *1. To withdraw your request, please press *2. Once again, to ask a question, please press *1.
We'll give the audio a second, and then we'll go back to the chat room.
Once again, to ask a question, please press *1. We do have a question from Michael. Your line is open.
Hi, thank you. Thank you, Dr. Schumacher. This was great. The question I have is, does the clinical hub also interact with, say, outside physician practices? In other words, the outside physician practices are creating these continuity care record documents. Does the clinical hub, can it receive that information, also process that through the text analytics as well?
That's actually one of the existing first edition would be the answer would be probably not. That's an issue, capability that we want to get in right away. So the only way that would happen is if the CCD was then put into an EMR and then the EMR triggered a message out, which is probably not the next one. But I think, Mike, it's a great question in that we are actually working with a group, and that's one of the reasons we moved to Webster Message Broker, is that they brought in a lot of CCD analysis capabilities. And so the next step would be able to bring in that information. And then that brings in sort of if you think about data I really trust, data I kind of trust, and data from the outside that I may not trust at all, we need to extend our model so that it's clear when people are searching what they're seeing. But the intent is to be able to bring in the CCD information. And then there's also the question of would you want to open this up to the community for them to be able to search a broader set of information. So that's one of the questions I think that we don't have an answer for that one, is that how would you install this in, say, a community HIE that allows it to have sort of a broader scope. But I think the first step to that would be able to take the CCD messages.
Operator, do we have any more questions?
There are no further questions at this time.
Okay, we have several, Scott, in the chat room here. Let's go back to the privacy discussion. And the question is, if you've got multiple facilities contributing data to the clinical hub, can you still do analytics just on one facility, either because that's their operational need, perhaps their privacy restrictions? We know we have lots of deployments. We have many people on the line here that represent Canada as well as the U.S.
Yeah, so that's a complicated question, by the way, and it's the same answer that you have about the privacy within the EMPI, and that is, yes, we do support it. We do support it from a point of view of display. So if I don't have access to a particular source of information, and I go pull back, and I pull back I query for that patient, I'm not going to get them. So it's the same role-based security that we have within the system that we have within the EMPI. So yes, it supports the notion of being able to combine data from multiple sources and putting that into a single repository, in this case the clinical hub. And then when you search, if you're not allowed to see the patient, or if you're not allowed to see an attribute of that patient, because you might have some restrictions that way, that you would not be able to see, you would not see that as a return. Either the patient would not be returned, or you wouldn't be able to see the particular attribute. Now, the one caveat to that is, and maybe this is a little too detailed, is that when I'm doing similarity calculations, so if I say A is similar to B, I will do it on the full sets of attributes available. So if you can't see all of those attributes, you might look at that and say, well, why the heck did you put those two patients together? So I won't display those attributes to you, but I don't have a way of pulling those out of the similarity calculation.
Ah.
So you would see that you'd say this patient's similar to this patient, but you may not quite know why. But again, you're dealing typically, unless you're an admin user, you're dealing with the de-identified data, the limited data set. So hopefully you wouldn't see those restrictions other than cases of, say, mental health clinics where you would not want to, you would not want information from that patient being in there.
Okay. Operator, any questions? Otherwise, we have more in the chat room.
There are no further questions at this time. Once again, to ask a question, please press *1.
Okay, Scott, here's another one from the chat room talking about the time frame of the medical history. Do we have any parameters or requirements or limitations, or is the time frame around what medical history can be considered a part of the longitudinal record, is that client dependent?
It's dependent only to the sense of, could you have the data available electronically to load it, right? I mean, our current VOC is going back and loading 2 years worth of clinical information, and that's, I think, probably a standard thing. And then going forward, it would be like the EMPI. No data ever goes away. You would keep those. At some point, you may wish to archive patients that you no longer see, but they still might be useful for you for doing outcome analysis. So you may wish to keep them around. But no, there's not a particular timeline limitation. It's really a matter of, do I have the data to support, how far back I want to go. And usually, so people who are doing the process of coming up with an EHR are fighting that same problem, right? So it's the same issue. And I think the people we have talked to have said, let's try to tie those pieces together so we have a consistent set of information.
Okay, thank you. Operator, any questions?
There are no questions at this time.
Okay. I'm looking at the chat room here, Scott. So you've talked in the discussion about the historical IBM Initiate, EMPI as some know it, the patient domain. Is that built into the clinical hub, or do they already have to license the IBM Initiate product? You or Deanna or Joaquin want to touch on that for just a moment?
Well, let's see. I'm probably not the right one to talk about licensing.
Yeah, Lorraine. This is Joaquin. Can you guys hear me?
Very good.
Okay, great. Yeah. So the current de-identification capability works directly with Initiate. So with MDM Standard Edition. So if you have that, that's the current model. But as Scott was describing earlier, because we're using Message Broker as an integration point, it's really not a big deal to integrate with some other system, so another existing EMPI solution with just some additional integration work.
Okay. Thank you, Joaquin. So, operator, any questions?
There are no questions at this time.
So then, to everyone, thank you for joining us. I hope you join us November 7th when we do our next in this series. We are going to talk about multi-domain master data management, and we will specifically address reference data management that Scott touched upon during this presentation. So we look forward to chatting with you again on November 7th. Thank you all.
Thank you for participating in today's conference call. You may disconnect at this